A hash function is an algorithmic or series of mathematical steps that you can perform on input data, resulting in a fingerprint or a hash. There are basic hash functions and cryptographic hash functions. Cryptographic hash functions are used extensively in blockchains. Let us go through an example of each of the functions. For a basic hash function, an example would be to use the first character of the input, which means that if we hash what is blockchain, the outcome would become W. The input of the function is referred to as the message, and the output of the function is referred to as the hash. Hash functions are said to be deterministic because the output is determined by the input. By definition of being deterministic, any specific hash function always produces the same output for any given input. Common examples of deterministic functions are addition, multiplication, subtraction, and division. A cryptographic hash function is special and has certain characteristics that makes it useful for cryptocurrencies. The ideal cryptographic hash function has 5 main properties. Number 1, it is deterministic, so the same input always results in the same hash. Number 2, it is quick to compute the hash value for any given input, i.e. you can easily go forwards. Number 3, it is not feasible to generate the input from its hash value, except by trying all possible inputs, i.e. you cannot go backwards. Number 4, a small change to an input should change the hash value so extensively that the new hash value appears uncorrelated with the old hash value. In other words, a small change to the input makes a big difference to the output. And number 5, it is not feasible to find 2 different messages with the same hash value, i.e. it is hard to create duplicate hashes or collisions. Properties 2 and 3 means that it is easy to create a hash from an input, but you cannot recreate the input from the hash. Based on property 4, you cannot guess or infer what the message may be by looking at the hash. The only possible way to go backwards is to try every possible combination of inputs and see if the hash value matches the one you are trying to reverse. This is called a brute force attack. So now we understand the parameters behind cryptographic hash functions. Let us put our basic hash function of putting the first letter of the sentence to the test. For number 1, yes, it is deterministic. What is blockchain always hashes to W. For number 2, yes, it is quick to compute as you just take the first character. For number 3, yes, by knowing only W, you cannot guess the original sentence. For number 4, no, a small change in the input does not necessarily change the output. For example, what is Bitcoin will still hash down to W. And for number 5, no, we cannot easily create inputs that will hash down to the same output W. So with this, we can conclude that this is not a good cryptographic hash function. In fact, there are established industry standard cryptographic hash functions that meets all the criteria. An example would be the secure hash algorithm, or SHA-256, which has the additional benefit in that the output is usually a fixed length. Hash functions can be used to prove that 2 things are the same without revealing the 2 things. For example, you can write a prediction down privately, hash it, and display the hash to others. Later on, you can review your prediction and others can calculate the hash and see that it matches to the hash you published. Cryptographic hashes are used in Bitcoin in the mining process as transaction identifiers and as identifiers for blocks in order to link them in a chain and to ensure that data tampering is immediately evident. In the next unit, we talk about the third key aspect of cryptography, digital signatures.